And so here's the paper that he cited, and let's zoom in on this a little bit more. Here are the reagents. Bruce is not using amino acids in water. He's not. He's got a carboxylic acid coupling with an amine. He does not have free amino acids. They're not amino acids. They're not zwitterionic. Now, he does the chemistry. It's got water around it, but the chemistry is happening in a hydrophobic pocket.
We are inside of a hydrophobic pocket.
He adds in organic compounds, large organic compounds, and these molecules slide in. What Dave Farina showed is that amino acids polymerize in water, not in a hydrophobic pocket. Even in the hydrophobic pocket that Bruce has, he's not doing amino acid coupling, no way, because they would never go in his hydrophobic pocket if they were zwitterionic. It wouldn't go in there. You can look, this is exactly the picture from Dave's video that he showed. He showed some ocean and the free amino acids coupling together. The free amino acids coupling together. This is what he showed repeatedly. And here's what I showed on the video is that amino acids exist in a zwitterionic form because this base takes that proton from that acid, and so you have an acid-base reaction within the same molecule. These are extremely water-soluble at this point. These don't go into hydrophobic pockets. So how did Bruce get his coupling to go? Because he didn't use these. What he did is he made this so it's no longer basic on one of the components, and he made this so it's no longer acidic on another component, and he took the acid and the base residues that were left and coupled those together. Those were not coupling of free amino acids. Now, I think Dave just doesn't know this. You could have learned something if you watched those videos with an open mind. You could have learned about this. So I'm teaching you again. I don't know if you're going to be teachable, but I hope you are. These are what amino acids are. They're zwitterionic, and they won't go into a hydrophobic pocket. They won't couple in water. Even your own expert, Lee, said that these favor the free amino acid, not the polypeptide when they're in water. That's why Lee gets rid of all the water by heating to well over the boiling point of water. He dries the thing out, and he drives those two molecules together. That's the way Lee does it. The way Bruce does it is what he does is he protects the amine group on one component so that it's no longer basic. So he puts a benzyl oxycarbonyl. It was formerly called carboxybenzyl. That's why they got the nomenclature CBZ for that protecting group. And with the acid, he converted it to an ester to leave just one amine here in a protonated state, but it's not zwitterionic, just leaving one amine and one carboxylic acid to couple. One amine coupling to one carboxylic acid. But this is just a normal carboxylic acid amine coupling. This is making an amide. This is not making a peptide linkage. This is not making a peptide in the sense that you have free amino acids. There are no free amino acids here. Nature doesn't have a CBZ group to protect this. Nature doesn't make esters to protect this, to do these couplings. Nature goes on the free amino acids, just like you showed on your picture, just like I said it can't happen. Let's look a little bit further at this paper, which you cite. Did you really open the paper and look at it? You put a copy of the front page. Every coupling that Bruce Lipshutz did, every coupling that he did had the CBZ group protecting the amine on one component, and every coupling that he did had an ester. Here's an ethyl ester, here's an allyl ester, ethyl ester, protecting the other end. Here's a methyl ester protecting the other end. So these are not free amino acids coupling. And why did he have to put these big CBZ groups on it? To make them hydrophobic so that they would go into his non-aqueous environment. So he functionalized the molecules to drive them away from the water and into the hydrophobic pocket, as he calls it. Every one of Bruce's free amines has an ester alpha to it, not a free acid. Every one of his amines that he doesn't want to use has a CBC group or a Bach group. That's a T-butoxycarbonyl group, another big moiety on there. None of these are amino acid coupling. None. Yes, of course he has activators too, but let's put that aside. He has these unnatural activators, which you cited, unnatural activators, but put that aside. There's no amino acid coupling. So when you say that peptide formation in water is absolutely no problem, you're absolutely wrong again. Also, none of his examples have side chains. Remember I showed you that list of amino acids. About half of them have active side chains. Some have OH groups, some have SH groups, some have NH2 groups, amine groups, some have carboxylic acid groups. You have to protect those or they would get involved. So this is a totally loaded system. Bruce Lipshutz was not coupling amino acids. None of his compounds were zwitterionic. Remember what I taught you about zwitterionic? Has a plus and a minus charge. None of his compounds had that, because when he puts a CBZ group there or a Bach group there, that amine is now alpha, and that amine is now hooked onto a carbonyl. Its lone pair is withdrawn. The electron density is withdrawn into the carbonyl, so it's no longer basic. All of his amines were protected. All of the carboxyl groups were esterified, the ones that he didn't want to undergo the reaction. All of his substrates were rendered minimally soluble in water because they were no longer zwitterionic, and he put big groups on the amines to drive those things into the hydrophobic pocket. All of his couplings were done in a hydrophobic pocket, not in water, but in a hydrophobic pocket. Yes, it may have been water surrounding that, but it was done in a hydrophobic pocket. It was done within an organic framework, not in water. So none of his chosen systems had active side chains. Bruce totally loaded this thing because active side chains would have thrown this thing off, and Bruce confesses to that, as you'll see. But most of all, he was not coupling amino acids. This was loaded to the extreme. No such joy for early Earth. If you're enjoying this series, give us a thumbs up and click the subscribe button, and that way you'll hear when we're coming out with new videos. There are no salaried employees in this organization. All the accounting, all the legal work, that's all done by friends of mine. The only thing that I have to pay for is the production work, and if you could help us out with that, I'd appreciate it. There's a link below where you can just click on that and help us in several different ways. Thank you.